Welcome to the next session where I am going to take up preparation and properties of phenols. So, in the previous class, just about 15 minutes back, I explained or solved some of the numerical problems. I gave introduction to phenols, where I explained what are phenols, their classification into the monohydric, dihydric and trihydric phenols, and then differences between alcohols and phenols. Phenols are more acidic, and in what way the acidic strength increases with the substituents. Okay? Right. See, we have different methods of preparation of phenol. Actually, all these methods can be called manufacture, because phenol is an industrially important compound. Phenol is an industrially important compound. Therefore, we study the methods used for the manufacture of phenols. Almost all methods are manufacture, that is large scale production of phenol. In what way phenol is an industrially important compound? The soaps which you use, you might have seen the advertisement. In soap slow na, is it a slow soap? See, they contain phenol and their derivatives. See, for example, Dettol belongs to the family of phenols. They are disinfectants and antiseptics. Disinfectants and antiseptics. Hello, Radhika. Hello. Okay. They are, so Dettol, phenol, carbolic acid, they are disinfectants, germicide, what they call germicide today, and antiseptics. And you know that phenol is used in the manufacture of Bakelite, used in the manufacture of Novolac. These are all industrial chemicals. Therefore, we have to study the manufacture of phenol, large scale production of phenol from different compounds. Which are those methods available for the preparation of phenols? One is from chlorobenzene. The first one is from chlorobenzene. How do you manufacture phenol from chlorobenzene? Okay, fine. How is chlorobenzene? Phenol is obtained from chlorobenzene. You take, yes, price rearrangement. I will tell you. I think I have explained that. First production by Dow's process. Okay, Radhika, I will come to that price arrangement in the next class. Okay, Mohana Potluri, I will come to that price rearrangement, because I have given a question on that and I have already explained. Okay, right. The first method of production of phenol is, as Radhika said, Dow's process. Dow process. Dow's process. So, usually wherever names come, we say first P, yes, it is not necessary. It is not necessary to write Dow's process, it is Dow process, that is all, DOW. Okay, right. Chlorobenzene to phenol. What type of reaction it is? What type of reaction it is? Anybody? I am not seeing the name of Vishwas Gowda here now. Yellodre. Okay. Mohana Potluri, can you tell me what type of reaction it is? This is nucleophilic substitution reaction. Nucleophilic substitution reaction. Yes, not only substitution, but nucleophilic substitution reaction. Since chlorine is connected to sp2 hybridized carbon atom, nucleophilic substitution is very difficult, very difficult, because chlorine is an electron pushing group because of resonance. It is very difficult to displace Cl by OH or substitute. Yes, Sunil, good evening. So, very difficult to conduct this nucleophilic substitution. Therefore, as Radhika has already made it clear, under drastic conditions. What are those drastic conditions? It should be under pressure and should be at higher temperature, should be at higher temperature and pressure. So, it is about 400 degrees Celsius, that is 673 Kelvin. Raghu, hello. Hello Raghu, good evening. 673 and at about 200, it may go up to 300 atmospheric pressure in presence of NaOH. So, if you heat chlorobenzene with NaOH at about 673, 350 Celsius, it may be slightly more also, it may not take place at exactly 350, it may go up to 400, and it is about 200 to 300 atmospheric pressure. Actually, you get sodium phenoxide. Sodium phenoxide on acidification gives phenol. Sodium phenoxide on acidification gives phenol. Okay. Roughly, you are right. Yes, it varies little from book to the book. Roughly about this 673 Kelvin and about 200 to 300 atmospheric pressure in presence of strong NaOH. It results in the formation of sodium phenoxide, which on acidification gives phenol. Okay, right. Next one. So, here also we can start from benzene. I will do other preparations from benzene, benzene plus chlorine in presence of ferric chloride. So, benzene chlorination will give chlorobenzene, chlorobenzene under drastic conditions with NaOH will form sodium phenoxide, sodium phenoxide on acidification gives phenol. Okay, right. The next one is again starting from benzene, again starting from benzene, right. Benzene is heated with concentrated sulfuric acid. It forms benzene sulfonic acid, benzene sulfonic acid. This benzene sulfonic acid If you fuse it with sodium hydroxide, fuse with sodium hydroxide, you get this compound. Second production by decarboxylation of salicylic acid. Okay, it's Radhika, it's just a preparation, not manufacture. Of course, it's a method used for the preparation of phenol. Okay, can anybody tell me the first product obtained, later it changes to something else. Now, can you tell me which product is obtained here? Yes, Jyotsna, hello, welcome to the session. Can you tell me which is the first product obtained which later undergoes decomposition? Anybody? Benzene sulfonic acid, if you fuse it with sodium hydroxide, you get something. Yes, anybody who can tell me the first product obtained in this reaction? Very simple reaction. Sodium hydroxide gives sodium phenoxide. Earlier to that, the first primary reaction, Mohana, primary reaction, primary product. Of course, it will be there in your book. You say sodium phenoxide. Simple. Sulfonic acid, this is an acid, NaOH is a base, therefore, it will form sodium benzene sulfonate, sodium benzene sulfonate. This further reacts with NaOH on heating. This gives, this is benzene sulfonic acid, this is benzene sodium sulfonate. This, if you continue heating, since you have added sodium hydroxide and fused, this will give sodium phenoxide, sodium phenoxide. Simple. Benzene sulfonic, the second step of the reaction is benzene sulfonic acid plus NaOH. Sulfonic acid, it is an acid, NaOH is a base, therefore, it will form salt SO3Na, sodium benzene sulfonate. This, if you continue heating with sodium hydroxide, you have already added sodium hydroxide and fused, you get this. This on acidification will give phenol. So, this is another method of getting phenol. Benzene, benzene sulfonic acid, fuse it with sodium hydroxide, benzene sodium benzene sulfonate, then sodium phenoxide, and then phenol, acidification. Sodium phenoxide, yes, this is sodium phenoxide. 1, 2, 3, 4 and 5. 4 is sodium phenoxide. Yes. So, two methods are already over, one from chlorobenzene, another from benzene sulfonic acid, or starting from benzene itself. Next, third one, I will come to the Radhika, I will come to that salicylic acid decarboxylation later. Third one is cumene process, very important method for the manufacture of benzene, phenol. You already know this method. I will just go through quickly. Benzene plus CH3, CH double bond CH2 in presence of orthophosphoric acid at about 523 Kelvin, similar to Friedel-Crafts alkylation reaction, it will give CH, CH3 and CH3, isopropyl benzene or cumene. This is cumene, isopropyl benzene equal to cumene. Yes, this is heated with oxygen. Again here the temperature the temperature varies from one book to the other. Many books do not suggest, but here it is heated in presence of a metal, in presence of a metal. Yes, cumene has the byproduct of acetone. Jyotsna, you are right. So you get C, CH3, CH3, OOH. Now, anybody, Jyotsna, Radhika and others, Mansi, if she is there, dilute HCl, then it forms phenol and acetone. Okay. So, what is this compound called and why is it called so? What is the name of this compound? 1, this is 2. What is the name of the compound 3? Why is it called so? Yes, anybody? What is the name of the compound 3? The latest, the last compound which I have written here. Compound number 3. This Radhika has already given the answer. In presence of HCl, that H plus will form, there will be rearrangement, it results in the formation of cumene hydroperoxide. Yes, you are right. Can you tell me why this is called so? COOH should be, yes, cumene hydroperoxide. Jyotsna, Mohana, you are right, but COOH group should be a carboxylic acid group. Why is it called peroxide? COOH, there is COOH group in 3, therefore, it must be a carboxylic acid. Why is it called a peroxide? So, you get phenol and then propanone or acetone, an industrial solvent, acetone or propanone, an industrial solvent. Why is it called peroxide? Is oxidized in presence of air. Why is it called a peroxide? Anybody? Why is it called a peroxide? Yes, because hydrogen peroxide has the formula HO, O and H, HOOH. One H is replaced by isopropyl benzene or cumene. H is replaced by cumene. Therefore, it is called cumene hydroperoxide. You can test it whether it is a carboxylic acid or a peroxide. You take this compound number 3, and add a strong acid, it will give hydrogen peroxide. Now, I would like to make myself clear here. I will write Some more examples for this. See here, BaO2 is called barium peroxide, Na2O2 is called sodium peroxide, PbO2 is called lead dioxide, NO2 is called nitrogen dioxide, whereas these two are peroxides. When do you call a compound peroxide? When do you call a compound dioxide? Then I will come to the preparation, other methods of preparation of phenol. When do you call compound peroxides? When do you call compounds dioxide? Anybody? Yes. Why do you call barium peroxide and sodium peroxide? Why do you call lead dioxide and nitrogen dioxide? What is the basis for this, for calling so? Yes? Yes. We should start chemistry from here. See, a peroxide is one. To this, if you add an acid, you get hydrogen peroxide. Then it is called a peroxide. O22, oxidation states, etc., come as a secondary one. Practically speaking, why BaO2 is called? We don't know the formula. We call it barium peroxide. We call it sodium peroxide. Whereas PbO2, lead dioxide, nitrogen dioxide. So, to this, if you add acid, no H2O2 is evolved. Therefore, these two are dioxides, those two are peroxides. Barium peroxide and sodium peroxide, if you add an acid, it will give hydrogen peroxide, even in presence of water. Even in presence of water, if you slightly warm, you get hydrogen peroxide. Hydrogen peroxide is obtained. Therefore, they are called peroxides. Even cumene peroxide also can be explained on the same basis. Okay? Right. Going back. Yes. Also it gives, yes. Going back to that, so cumene acetone is the byproduct of the cumene manufacture of phenol. Okay, chlorobenzene is over, benzene sulfonic acid is over, cumene process is over. When it reacts with acid, yes, when it reacts with acid, it will give hydrogen peroxide. Even when it reacts with water, slightly warming, it will give hydrogen peroxide. Okay. The next method of preparation is from aniline. So, your books say from benzene diazonium chloride, but benzene diazonium chloride is not available readily. It should be always prepared from aniline. Aniline is treated with NaNO2 plus HCl between 0 and 5 degrees Celsius. Okay. Thank you. So, aniline, this is called diazotization reaction. Diazotization. This will give benzene diazonium chloride, N2 plus and Cl minus, benzene diazonium chloride. Why is it called diazonium chloride? Yes, others continuously Radhika is answering. What about others? Mohana, Mansi and others. Okay, don't hesitate to answer. Radhika, you continue. It is a good thing. You have studied chemistry probably in deep when compared to others. Okay. Now, this is called diazotization. Why is it called benzene diazonium chloride? This benzene diazonium chloride is soluble in water. So, you always get benzene diazonium chloride in water. Double bond N, double bond N, Jyotsna. Okay. See, I would like to give you the original name of nitrogen is azote, a French name. Azote means lifeless or inert, lifeless or inert. Since this compound contains 2 nitrogen atoms, it is called diazo. It is a salt, hence diazonium salt. Diazonium salt. The original name of nitrogen is azote. It is a French name, means lifeless or inert. Azote, not azo, Jyotsna. It has been derived from the word azote. Azodite test, yes, you are right, N double bond N. So, that diazo, azo has come from the word azote. So, if you boil this solution at about 70 degrees Celsius, that is 343 Kelvin, it results in the formation of phenol. So, it results in the formation of phenol. If you boil this solution, benzene diazonium chloride, N triple bond N, okay, Jyotsna, okay, fine, N triple bond N plus and Cl minus. So, if you boil this solution, it is already present in water. If you boil it to 70 degrees, it results in the formation of phenol. The first step of the reaction is called diazotization. Introduction: 2 nitrogen atoms are present in the compound benzene diazonium chloride. Okay. Next one is the last one, which Radhika has already said, salicylic acid. OH and COOH. If you heat it with soda lime, first you get, you need not write this, but still I am writing COONA. If you heat it with sodium hydroxide, again further you get phenol with decarboxylation and sodium carbonate plus water, Na2CO3 plus H2O is obtained. This is how the reaction takes place. Salicylic acid minus CO2 will give phenol. It is just the repetition of the method that has been already told by Radhika. Okay. So, this will give phenol. So, we have prepared phenol from chlorobenzene by drastic condition, the nucleophilic substitution reaction, and then from benzene sulfonic acid, fuse it with sodium hydroxide. Third method, cumene process. Yes, cumene process is also over. Fourth one, aniline diazotization, benzene diazonium chloride, boil and then the last one, this is just preparation. Others are usually called manufacture. The previous one and this are called preparation. In small scale, it can be prepared by these methods. Okay, right. The next. So, previous session contest question, acid catalyzed hydration of ethene forms A. This is heated with alkaline chlorine to get B. This, when heated with an acid, undergoes hydrolysis to give C. Write equations. I heard that nobody has answered this question. So, I will write it now. CH2, double bond CH2 on hydration, addition of water in presence of an acid, will give CH3 CH2 OH. If you heat it with chlorine and an alkali like sodium hydroxide, I will write the series of reactions. The reactions are like this. First, CH3 CHO, chlorine oxidizes ethanol to acetaldehyde. This acetaldehyde again reacts with chlorine to form CCl3 CHO, chlorol or trichloroacetaldehyde. This will react with NaOH to form CHCl3 plus HCOONA. Chloroform, just like iodoform reaction. This is chloroform. This chloroform, if you hydrolyze it, which you already have answered this question last time, if you hydrolyze this in presence of an acid, you get HCOH, OH and OH, which is unstable, immediately undergoes dehydration to give formic acid. Therefore, C is formic acid. A is ethanol, B is chloroform, a series of reactions, alkaline chlorine, and C is formic acid. Formic acid. Okay, does not matter. You may not be in a position to answer such questions immediately, but if I give you some more questions of this type, you will be in a position to answer. I am sure that you will answer such questions clearly and correctly with some practice. Okay, fine. Nobody is a winner. So, preparation and properties of phenol. So, now the contest time for this session. Benzene is heated with nitric acid and sulfuric acid. It will give compound B. B, when again heated with nitric acid and sulfuric acid, it forms C. C is treated with tin and HCl, will give D. Now, I will come to the properties of phenol. Properties of phenol. The properties of phenol are studied under different headings, of which I will take up yes, Aditya, Radhika, Smaranika, all of you have said answer D, excellent. Radhika, Aditya, Mansi, excellent. D is the answer. Okay. So, now coming to the properties of phenols. I do not want to, Kumar Reddy, you are right. Now, coming to the properties. So, I will write reaction with sodium, reaction with sodium hydroxide, then reaction with zinc metal, reaction with acidified potassium dichromate, then electrophilic substitution reactions, then special reactions, Reimer-Tiemann reaction, then Kolb-Schmidt, SCH-MIDT, Kolb-Schmidt reaction. Yes. So, I am also congratulating all those who have given answer D, because the first one is nitrobenzene. If you further nitrate, you get metadinitrobenzene, which on reduction NO2 becomes NH2. Fine, excellent. Okay, we shall see these reactions one by one. C6H5OH plus Na, these are all two preliminary, still we should know it. So, it will form sodium phenoxide with the liberation of hydrogen. This reaction is similar to alcohol. Alcohols also give or liberate hydrogen from sodium metal, similar to alcohols. The second one is C6H5OH plus NaOH. It will form C6H5ONa plus H2O. This is salt, this is water, this is a base. This clearly shows that phenol is acidic in nature. The reaction, the first reaction and the second reaction show that phenol is acidic in nature. The H can come out as H plus, it is a proton donor. So, these two reactions clearly indicate that phenol is acidic in nature. Basic salt, yes, with NaOH. So, it will form a salt, the basic salt with sodium hydroxide. Therefore, phenol is acidic in nature. The next one, if you heat it with zinc dust, phenol with zinc dust, metals are very good reducing agents. Here zinc dust, where the surface area is very high, it will take away oxygen, hence it will be reduced to benzene plus ZnO. it is benzene. Zinc will reduce phenol to benzene. Okay. See, phenol is a colorless crystalline solid. Colorless crystalline solid. If you expose, benzene forms after reaching with zinc dust. Yes, after reacting with zinc dust, correct. You have to heat it. Zinc should be in the form of a dust, fine particles of zinc. The surface area should be maximum. So, with zinc dust, if you heat it, it forms benzene. Phenol is a colorless crystalline solid. If you expose it to air, slowly it becomes yellow, brown, etc. and finally it becomes pinkish brown. Pinkish brown. This is due to oxidation, air oxidation. Phenol is prone for oxidation. It will form a series of benzoquinones. Quinones are formed. Same reaction, instead of air, use an oxidizing agent. So, I will go back. Use potassium dichromate and H plus. Instead of air, we use potassium dichromate and acid. Phenol, if you heat it with potassium dichromate, which is acidified with the dilute sulfuric acid, it is slightly soluble in water. Yes, it is slightly soluble in water. Yes, correct. Coming to the physical properties, those are physical properties. It forms quinone. So, it undergoes oxidation giving quinone. Therefore, the color slowly changes. Mohana has said it is slightly soluble in water. Yes, sparingly soluble in water. That is why if you take a bucket of water and add a few drops of phenol or carbolic acid, it is also called carbolic acid, you get turbidity at the top. You stir it, it becomes clear solution. Okay. So, the oxidation will take place if you continuously expose it to the air or by heating it with potassium dichromate, acidified potassium dichromate. Okay, here Mohana, since you have given that sparingly soluble in water, I would like to give you a little more explanation for this. You take 90% phenol plus 10% water, they mix with each other, soluble. If you take 95% phenol, 5% water, soluble. You take 5% phenol, 95% water, it is soluble. You take 50% phenol and 50% water, it will form turbid, it becomes turbid, means it is not soluble or sparingly soluble. So, if phenol is in excess, water in small quantities, they mix with each other. This is for this sentence, it is slightly soluble in water given by Mohana Patluri. the explanation. So, if water is in excess or phenol is in excess, they are soluble, but if they are present in equal quantities or slight difference, it will form a turbid layer. But above 68 degree Celsius, above 68 degree Celsius, phenol plus water are completely miscible, or completely miscible. This temperature is called miscibility temperature of phenol water system. Miscibility temperature of phenol water system. Phenol water system. Okay. So, this is I will continue this in the next class. So, today we heard something about the manufacture of phenol from chlorobenzene, benzene sulfonic acid, from cumene, etc. And then thank you for joining us. So, for those the passport question, you may start answering. Get access to the class practice packs sent by your teacher with the passport. Okay. Thanks for joining. I hope I made myself some of the new concepts clear. Okay. Fine. We shall take up the properties of phenol, continue in the next class. Thank you very much.